Hello everyone. Today we are going to discuss a numerical related to centrifugal pump. So let's start. The internal and external diameters of the impeller of a centrifugal pump are 200 mm and 400 mm respectively. The pump is running at 1200 rpm. The vane angles of the impeller at inlet and outlet are 20° and 30° respectively. The water enters the impeller radially. The velocity of flow is constant. Determine the work done by the impeller per unit weight of the water. The figure shows the velocity triangle diagrams at inlet and outlet. This V1 represents the absolute velocity of the water at inlet. This U1 represents the tangential velocity of the impeller at inlet, and hence this VR1 will represent the relative velocity of the water at inlet. The water enters the impeller radially, so the value of alpha will be equal to 90° and hence the velocity of whirl at inlet Vw1 will be 0. So the value of V1 will be equal to velocity of flow at inlet, which is Vf1. This angle theta represents the vane angle at inlet. Now let's see the velocity triangle diagram at outlet. This V2 represents the absolute velocity of the water at outlet. Vf2 represents the velocity of flow at outlet. Vw2 represents the velocity of whirl at outlet. This U2 represents the tangential velocity of the impeller at outlet. And this Vr2 represents the relative velocity at outlet. Phi represents the vane angle at outlet. And this angle beta represents the angle made by the V2 with the direction of motion of vane at outlet. Now it is given in the numerical that the vane angles of the impeller at inlet and outlet are 20° and 30° respectively. So the value of theta is given as 20° and the value of phi is given as 30°. Now as per the given data in the numerical, internal diameter of the impeller D1 is equal to 200 mm, which is equal to 0.2 meter, and external diameter of the impeller D2 is equal to 400 mm, which is equal to 0.4 meter. The vane angle at inlet theta is equal to 20°, and the vane angle at outlet phi is equal to 30°. As water enters the impeller radially, so alpha is equal to 90°, and hence the value of velocity of whirl at inlet will be equal to 0. Now the tangential velocity of the impeller at inlet can be calculated by using the formula U1 is equal to pi d1n by 60. So it is equal to pi into d1 has the value 0.2 multiplied by n is 1200 divided by 60. So U1 is equal to 12.56 meter per second. Similarly, tangential velocity of the impeller at outlet can be calculated by using the formula U2 is equal to pi d2n by 60, which is equal to pi into 0.4 into 1200 divided by 60. So U2 is equal to 25.13 meter per second. Now we have to observe the velocity triangle diagram at inlet. See this velocity triangle diagram at inlet. Here we can see that tan theta is equal to Vf1 divided by U1. We have already calculated the value of U1 and we already know the value of theta. So the value of Vf1 can be easily calculated. So tan theta is equal to Vf1 by U1. Vf1 we have to calculate. U1 we have already calculated as 12.56 meter per second and theta is given as 20°. So Vf1 is equal to U1 tan theta is equal to 12.56 multiplied by tan 20°. So Vf1 is equal to 4.57 meter per second, and as velocity of flow is constant, so Vf2, which is the velocity of flow at outlet, is equal to Vf1, which is the velocity of flow at inlet, and both are equal to 4.57 meter per second. Now we have to observe the velocity triangle diagram at outlet. You can see that this is the velocity triangle diagram at outlet. Here you can observe that tan phi is equal to Vf2 divided by this, and this is equal to U2 minus VW2. So this is equal to U2 minus VW2. So we can say that tan phi is equal to Vf2 divided by U2 minus VW2. So tan phi is equal to Vf2 divided by U2 minus VW2. Vf2 we already know, it is 4.57 meter per second, and U2 we have already calculated as 25.13 meter per second. Phi is given as 30 degree, so tan 30 is equal to 4.57 divided by 25.13 minus VW2. From here we can calculate the value of VW2 as 17.215 meter per second. We know that the work done by the impeller per unit weight of the water in 1 second is given by 1 by G VW2 into U2. We have already calculated the value of VW2 as 17.215 meter per second and the value of U2 as 25.13 meter per second. So the work done by the impeller per unit weight of the water in 1 second is given by 1 by 9.81 multiplied by 17.215 multiplied by 25.13, which is equal to 44.1 Newton meter per Newton. So this is all for today. Thanks for watching this video. Thank you.